If there's one thing that we like in Wizarducks and the Lost Tap, besides, ducks, it is making grass that sways in the breeze. Now, this is not an overly complicated effect to achieve, but it does require use of some of the more obscure sprite drawing functions in GameMaker, and I have been saying for a while that I want to make more videos on some of the more interesting effects that we've been pulling in Wizarducks and the Lost Tap. So, hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about draw sprite position. Before I actually start writing any GameMaker code, I'm going to jump into an image editor and we're going to talk about shear transforms for a little bit. So, in pretty much any image editor that you might use in the modern day, there will be some sort of tool that will allow you to do some kind of shear transformation. So for those who have never come across this before, a shear transformation is another way of stretching an image, but instead of, for example, stretching the sides or the corners and preserving like the interior angles of a sprite like you might do by like making an image bigger or smaller like this. What a shear transformation is going to do is it's going to pull on the top and bottom or the left and right sides of the sprite, and it will basically turn the sprite from a square or at least a rectangle and into some kind of like funny irregular parallelogram. So if I were to go and play around with the horizontal shear in PhotoP's free transform, you'll see that if I were to move it left or right, we will have this grass sprite sort of like getting bent out of shape, again, as if it was some sort of weird like parallelogram. If I were to reset this, by default, we are going to be transforming this around the center, which is, in this case, not really what I want, so I will set the origin of transformation down to the bottom center so that when I play with the horizontal shear, we can move the top left and right, but the bottom will stay where it is. And this is going to be the basis of our grass swaying in the breeze. You can do this with the vertical, like the left and right sides, as well as the top and bottom if you want, for some reason, a vertical shear. That is going to be less useful to us for making grass dance around in the breeze. So, armed with that knowledge, let's go back to GameMaker. So in my test project here, I have just a couple of grass sprites. I'm actually going to, you know what? Let me go and delete 2 of these. I think I only need 1 to start out with. So we are going to run this game, and we are going to have a grass sprite. It's going to be a little bit zoomed in to make it easier to see. And how are we going to go about shearing this sprite so that the top side of the sprite is going to like wobble back and forth while leaving the bottom of the sprite where it is? So what are you going to need going into this? So like I said at the beginning, this is not an extremely difficult effect to pull off, but it is going to rely on some of the more obscure functions in GameMaker for sprite drawing. So you should be at the point in your GameMaker studies where if I use a sprite drawing function that you've never seen before, you won't be like completely thrown through a loop. We're also going to be using some trigonometry here. I'm going to be using some equations that involve sines and cosines to make a value oscillate back and forth in a cyclical pattern. So I suppose I might say that you'll probably want to know enough about trigonometry to recognize where it stops applying to triangles and starts applying to circles.
Hey.
But other than that, I don't think there's going to be anything too crazy in here, so let's get started. GameMaker does not have a function that is like draw sprite shear or anything like that, as much as maybe we wish it did. Our second best option is going to be draw sprite position. This is definitely one of the more obscure sprite drawing functions in GameMaker. So usually when you would draw a sprite, you would just say like draw sprite, or maybe draw sprite extended, or draw sprite stretched if you're interested in like a free transform. There's a couple of other sprite drawing functions in GameMaker, but the one that we are going to be using today is going to be draw sprite position. And this differs from the regular sprite drawing functions in GameMaker because instead of giving this function like an x scale or a y scale or a sprite width and a sprite height, we are going to give this function 4 coordinates that are going to correspond to the 4 corners of the sprite, and GameMaker will attempt to stretch the sprite to fill those 4 corners. So one thing that I will be using in this video is I'm going to be making use of a lot of built-in sprite variables in GameMaker. So we obviously have sprite index and like image index for the sprite in the frame of the sprite that an object belongs is like represented by. But there's also a bunch of other built-in sprite-related variables in GameMaker that are things like sprite width and sprite x offset and that sort of thing. And I'm going to be making use of a lot of these, largely because if you were to use the like sprite get width and related functions everything I write would be like 3 times as long, and I don't really want to do that. So you might not use GameMaker's built-in like sprite width and sprite get x offset variables that often, but I am going to be making use of them fairly heavily here. If you are, for whatever reason, like not using GameMaker objects for this, or if you're using a GameMaker object that doesn't have a sprite set to it and you're trying to just do this with a regular sprite, you generally will be able to replace those like sprite width and sprite whatever values, sprite bbox, sprite whatever, with just like a couple extra lines of code using the sprite accessor functions. But I'm gonna not be doing that because again, I don't want everything that I write to have to be like twice as long. So the draw sprite position function, we're going to be going to sprite index. I guess we can also say image index too if we want to have like animated grass or something. This is probably not something that you'll be doing with animated grass because that would look kind of weird. But we are going to want to pass this function in x1, y1, x2, y2, x3, y3, and x4, y4. And oddly enough, draw sprite position takes an alpha argument for transparency, but it doesn't take a color argument. Most other like sprite drawing functions that will take a transparency value for the sprite will also take a color. I do not know what's with that. When I say that this is one of the more obscure and or more forgotten functions in GameMaker, it's possible that that applies to Yo-Yo games too. No idea what's going on with this. So we need to figure out values for these x1, y1, and whatever coordinates. So like I said, this is going to correspond to the different corners of the sprite. So these, I don't believe this is like documented. At least like the feather dock that pops up when you mouse over the function doesn't say. But x1, y1 is going to be the upper left corner of the sprite. x2, y2 is going to be the upper right corner of the sprite. x3, y3 is going to be the lower right corner of the sprite. And x4, y4 is going to be the lower left corner. So it basically starts in the upper left and goes clockwise around the sprite. So let's start filling these in. So there's going to be more to this later. But first I'm just going to say x1 equals x. Var y1 equals y, var x2 equals x, and this is going to be the right side of the sprite, so that's going to be x plus the sprite's width, which we can figure out with x plus sprite width. Var y2 is going to be y because it's still on the top. Var x3 is going to be x plus sprite width because this is the bottom right, and y3 is going to be y plus sprite height. And lastly, var x4 is going to be x. Var y4 is going to y54. Y4 is going to be y plus sprite height. So if I space these out a little bit, we're gonna have 4 corners of the sprite. Once the code syntax highlighting catches up, we'll see that we have all our variables. I had to wait for that because it would not have been wholly surprising to me if I'd managed to misspell a two-letter variable name. But now if I do this, we are going to have the sprite being drawn. If you want to see just real fast some consequences of fooling around with this, if I were to say x2 equals like sprite width divided by 2, we will have the upper right corner of the sprite being like drawn in somewhat towards the upper left like this. It looks a little weird. So that is draw sprite position. So this might look a little bit different from when I ran this at the beginning of the video, and we will get to that in a minute. There's one and possibly 2 things that you might want to bear in mind when doing this, but I do want to deliver on the promise of this video before like the very end. So first, let's look at some timing variable. I'm going to say var time equals, and there's a couple different methods of doing timing in GameMaker. In most cases, my preferred one is going to be using the variable called current time. This is a built-in variable to GameMaker, which represents the number of milliseconds since the game has started. So at 1 second, it will be 1,000. 2 seconds after the game starts, it'll be 2,000. 10 seconds after the game starts, it'll be 10,000. If I want to turn this into the number of seconds since the game has started, I can simply divide that by 1,000 to turn milliseconds into seconds. And if I wanted to make, for example, the top side of the sprite move over time, we could say x1 equals x plus time, x2 equals x plus sprite width plus time. We leave the bottom side alone. We leave the bottom 2 alone because we want only the top sides of the sprite to move over time. And if I run this, we can see that over time, this the top side of the sprite is going to start getting like pushed off to the right, but the bottom side is going to stay where it is. All right, so that's not like wind or anything. If we wanted wind, we would probably want to look at some trigonometry, like I said. so that we could use some sort of cyclical motion, for example, a cosine function. If I were to say, let's call it time offset. Let's say, for example, time offset equals the cosine of time. If I just run this, this is not going to do a lot. Let's go and replace x plus time, x plus sprite with plus time with time offset so that we're actually using that cosine value. If I just run this, we are going to have some wobbling back and forth, but it's not going to be like a really extreme amount. I'm not quite sure if I could put my cursor on like the farthest left and right that it gets, but I think the farthest right that it gets is about here, and the farthest left that it gets is maybe like over here. So it's, you know, a pixel shifted left or right, because the cosine function and the sine function have a range of -1 to +1. If we wanted to make the wiggle a little bit more dramatic, we could multiply this by some bigger value. So something like 6 times cosine of time, I think, should make the wiggle a little bit more dramatic. And indeed it is. If this is going a little bit slow for us, we could mess with values inside this cosine function. For example, multiplying the time in seconds by 2. So the cosine function and the sine function in GameMaker will take their inputs in radians instead of degrees. The degree versions of the functions are dcos and dsine, but radians have a cycle of 2 pi, so that'll be about 6.3 seconds for a full like repetition of this pattern. If you multiply this by 2, we will speed that up, and we can have the grass shaking back and forth a little bit faster than it was before. And I think that's good enough for now. We've got some semblance of grass swaying in the breeze right now. There are some people who will get very fussy about like straight sine and cosine waves being used for something like this, and saying that like that's not how grass shakes in real life. There's like spring forces and the Hooke's law and other bits of math at play. But you know what? For something that you can do in like 2 lines of code, that's not bad. You can obviously plug in any other function that you want for like periodic motion in here, but I think for the purpose of a tutorial video, I'm going to invoke the keep it simple stupid rule. So before I move on to fixing some of the things that I mentioned, Windows, I should probably like find a way to turn this off because this is kind of annoying. But before I move on to fixing some of the things that I said might need fixing later, let me make a commit. So that's going to be our basic grass sway. So getting back to the beginning of the video, you might have noticed that the sprite is actually being drawn in a slightly different location than it was originally. And that is due to the location of the sprite origin. So if you set the sprite origin to the upper left, then what I've written here will be like just correct, and you won't have to worry about weird sprite offsets or anything like that. But if I set it to the bottom center, like I said we were going to do in when I was messing around in Photopea, you're going to have to do a little bit of extra math to get the sprite back in the like original location if you use draw sprite position like this. So to illustrate what I mean, let me put at the top draw sprite extended, and I'm just going to draw kind of like a ghost copy of the sprite behind the one that we're actually looking at. So let's draw our sprite index, our image index. X can be X, Y can be Y. X scale, image, X scale, image, Y scale. Rotation can be 0. I'm not looking at rotation right now. Color. I'm going to draw this just like a slightly darkened like gray value. So something like, I don't know, 666666 and an alpha of 1. And that is going to draw a copy of the sprite in the background, sort of like faded out to black. And we can see that that sprite and the one that we're drawing with draw sprite position is actually not really in the same location. And again, that is because of the location of the sprite origin. So what we'll need to do is we'll need to basically subtract the coordinates of the sprite origin from our X and our Y before we draw them. And these two are, there are functions that you can use to access this information from a sprite, like sprite get X offset, sprite get Y offset, like that. But there are also built-in instance sprite variables that pertain to this. So X. So in our case, we can say sprite X offset. I think this was one of the ones that I mentioned at the beginning of the video. So sprite X offset is going to represent the like, it's just a convenient variable that you can use to get the offset of the current sprite index. It also accounts for things like image X scale, image Y scale, stuff like that. So in every single one of these coordinates, I'm going to subtract the x offset and the sprite y offset from the actual x and y that we're drawing. So that's going to be in x1, x2, x3, and x4. And we will do the same thing for y, like this. And now if I run the game, with that change in mind, we can run this and we can see that the grass is being drawn in the correct location, properly accounting for the x and y origin of the sprite. And of course, the sprite is waving back and forth on top of that. That looks pretty nice. So that is an easy fix. Once you know what's going on, you just have to subtract the correct values from the location of every corner to make sure that the corners are like in the right place. Something that's going to be a little bit more difficult is if you have a sprite, and this is probably going to be pretty common for most of the sprites that you actually draw. If you have a sprite, let's say that it's got some white space hanging off the end. So I'm going to say, let's resize this canvas. The width can be like 64 and the height can be like 40. I want this to be like maybe a little bit bigger than will be realistic, but it needs to be big enough that you can actually see what's going on. And if I run this now, this is going to look a little bit funny, and we'll see that the grass sprite has been awkwardly stretched when we do this. And this is something that you will have to worry about if you use draw sprite position. If I comment this out and if I just look at the original sprite, which wasn't even visible behind it because it was being completely obscured, we can see that if you draw a sprite with like draw sprite extended or one of the normal sprite drawing functions, you don't really have to worry about this because GameMaker, if it has white space hanging off the end of a sprite, it knows what to do with this. But if you if you directly try and set the corner values, then you're gonna have to suddenly deal with this. So the reason that this happens is that when GameMaker builds your game and the ASCII compiler runs, it will actually trim off all white space around sprites, at least by default. And that's just because there is no reason to have to spend storage in your game files on an amount of space that is just empty pixels. There's no reason to have to load all this space that's just empty pixels into VRAM when your game runs. It's kind of just a waste of space. It's not something that you'll ever actually be able to see. So GameMaker will actually crop off white space like that for you. Most of the time, this is what you want because GameMaker's regular sprite drawing functions will compensate for that when it figures out what the bounds of the sprite are when you go to draw them. But if we have to deal with this ourselves, the easy way to do this is to basically disable that cropping behavior. You can go to Tools, Texture Groups up here, and in whatever texture group that your sprite lives on, so in my case it's the default texture group. If you have other texture groups, you might use another texture group for grasses and stuff. But we can uncheck the automatically crop checkbox over here. And that will disable the white space cropping behavior of the GameMaker ASCII compiler. And now if I run this, we'll see that our grass sprite is back to normal because our sprite is the full size. Oh, I was gonna say why is this here? Why is this checker box pattern here? But I then realized that if you click on a sprite in the texture group, it'll show it there. Anyway, that's the easy way to deal with this. It might or might not be practical. If you have a lot of sprites that look like this and they don't all fill up the canvas that they're sitting on, if there is a lot of white space on each of these, that can add up to a lot of space on the texture page that maybe you don't want to just waste. So while unchecking the automatically crop checkbox is a perfectly valid solution, we're also going to look at what you can do, what math you can do to get around this. So unfortunately, there is no convenient built-in variable for things like sprite x offset, sprite y offset. Unfortunately, there's no convenient way of accessing the amount of space that was trimmed off of a sprite on the left, right, top, and bottom. But there is a function, sprites get UVs, and this is a function which mainly pertains to how a sprite has been written to the texture page. It will return an array of a couple different values, and there are 4 values in particular that we're interested in. if I mouse over this, is it actually going to tell me what they are? It is not. So if you hit F1, you can open up the documentation and you can see what exactly this function will return. The first 4 are just texture coordinates of the location of the sprite on a texture page. This is probably not something you're especially interested in right now. The thing that we're interested in is going to be the bottom 4. So this is going to be the amount of pixels that the asset compiler has trimmed off the top and off the left, and the amount of pixel data that has, the percentage of pixel data basically, which has been saved horizontally and vertically. I don't know why it returns this in terms of normalized percentage instead of just like a number of pixels, but we can make use of this all the same. So to restate the problem, and I will try to actually represent what's going on visually somehow, sprite width and sprite height, and also the function sprite get width and sprite get height, those will return the, what we'll call the official dimensions of the sprite, so 64 by 40 here. But since GameMaker will by default crop the sprite to the dimensions that look something like this, when it goes to draw a sprite, it can't simply like draw this entire region because the sprite has been cropped. On the texture pages, the texture atlases the GameMaker uses, if you go to the left or the right or the top or the bottom, you might run into image data that belongs to some other sprite or font or tile set or something like that. And if you were to draw the full region, you would get nonsense data. So when you call draw sprite or draw sprite extended or that kind of thing, GameMaker will do a little bit of arithmetic to subtract and or add the dimensions that have been cropped off the sides or the top and the bottom, but it will not do that when you say draw sprite position, so we need to do that ourselves. So firstly, let me actually reset the sprite origin so that it's on the bottom of the sprite and not some distance away from it, because that'll make our lives a little bit easier. If I were to, instead of saying draw sprite position like this, if I were to say like draw rectangle, our x1 can be x1, y1. Our x2 in this rectangle can be the opposite corner, and that's going to need to be x3, y3. Outline only, let's make that false. And if I were to again draw, draw the sprite using draw sprite extended, after this we can we'll be able to see the region. All right, how about we disable the wave for now, because that is distracting. If I did this, we'll be able to see the full, the official size of the sprite versus the size of the sprite that we're actually interested in. We need to figure out how to draw a rectangle that is simply going to encompass the actual visible part of the sprite. All right, so going back to sprite get UVs, I'm going to say var UVs equals sprite get UVs. This is going to take 2 arguments, sprite, index, and image. Index in my case. So the amount of pixels that were cropped off of the left of the sprite is going to be UVs index 4, and the number of pixels that have been cropped off the top are going to be UVs index 5. This does not account for any image X scale, image Y scale that you might have applied to your sprite. This is just the number of pixels that have been cropped off the texture. So unlike when you just say sprite width and sprite height, and that automatically accounts for image X scale, image Y scale, if you want the amount of pixels that have been cropped off of a sprite accounting for scaling, we're going to have to multiply that by image X scale and UVs index 5 by image Y scale. I should give these variable names, so var crop left, we can call that, and var crop, that's the top, right? Crop top. And we can add this into the left side and the top side of the sprite in our x1, y1, etc. So if I were to say x1 equals all that, we can throw another term onto this, which is going to be plus crop left. And y1, we are going to say plus crop top. X2, we'll need to figure this out later, but y2 is also going to be plus crop top. X3 is neither, and x4 we will want to add in crop left. So the rest of these values, we'll need to figure out how much space was cropped off of the right and the bottom. That is going to be a little bit less straightforward. So because UV's index 6 and UV's index 7 are the normalized percentage of the pixel data that has been written to the texture page or whatever, that means it's going to be a value between 0 and 1. 0 means that none of the original sprite will have been written to the texture page, and 1 means that 100% of it will. So if, like, in this case, it's going to be about half of the sprite that was actually saved to the texture page, so that'll be about 0.5. If you want to figure out how much was removed from the right side, we can say sprite width minus, in parentheses, UV's index 6 multiplied by sprite width minus crop left. You could also use sprite get width like this, but then you would have to multiply like the whole thing, like all the relevant terms, by image x scale, image y scale. Again, it's just much less code if you use your sprite variables. I would recommend using your sprite variables in GameMaker when applicable, because it just makes everything easier to work with. Anyway, our crop bottom can be the same thing basically, but sprite height minus, in parentheses, UV's index 7 times sprite height minus crop bottom, and I mean minus crop top. And these values, instead of adding them to like y2 and y1 and whatever, we are going to subtract these from the right side and the bottom side of the sprite coordinates. So x2 is going to be on the right side, so we can say that minus crop right, y2 is fine. x3 is on the right side, so minus crop right. Y3 is on the bottom, so minus crop height. Why is height so hard to spell? Crop height, crop bottom. And Y4 minus crop bottom. And now, after all that, if I run the game, we are going to have our draw sprite position sprite being drawn in exactly the same place as our original. If I were to re-enable the grass sway, we can see that we are going to have what we had before, but it is now going to properly account for any and all space that was trimmed off of the sprite when we did our texture thing, when we built the game, because of the automatic cropping. Okay, so I think that is good for another commit. We can say not the most helpful commit message that I've ever written, but it'll get the job done. So there's two more things that some of you might or might not have already yelled at me about, which might come up when you do this. One is that it is possible to use a matrix transform to do this instead of using draw sprite position. I would not recommend doing that. I think that is fairly overkill. Using a matrix transform make you not have to deal with all of this nonsense with like figuring out the corners, but GameMaker doesn't have a way of just creating a shear matrix the way that it has for creating a translation, rotation, or scale matrix, which means that you're going to have to build a shear matrix just like by hand, element by element, which I think is beyond the scope of this video. And it also means when you do this, when you use matrix transforms for every single sprite, that is not the ideal, efficient way of drawing things in GameMaker. If you're the sort of person who's interested in using matrix transforms for everything, I'm sure you know that, but just something to keep in mind. So now that we are done with the warnings, let's get back to some fun stuff. So I'm going to go and, let's say, disable this grid, and I'm just going to slap down a bunch of these grass objects, and we're going to run the game with all these in the room at once. And I think that should be good enough. Let's get out of there. I'm going to do a little bit of primitive depth sorting by going into the grass object create event and just saying depth equals -y. Most famous line of code in GameMaker. And now if I run this, we are going to have... I should probably disable the shadow copy of the grass being drawn behind the waving grass sprites so that they don't like draw that on top of each other. And if we do this, we have a bunch of grass all waving in synchrony. So that's all right. You might or might not want all of your grass to be waving in synchrony like this. You might want all of these pieces of grass to have some kind of like random offset so that they wave at different speeds or at different rates. And you can do a few things. So you can take either the coefficients that we're sticking in this time offset calculation, and you can make each of these an instance variable, and you can say that like the amplitude is like a random range between like, I don't know, 5 and 7 or something like that. And the period modifier here is can be a random number between like 1 and 3 or something like that. I'm actually not going to do that. I'm going to go and go with the third option. And we are going to go into the create event of each of these grass objects and say a random offset value is going to be a random number between, let's say, 0 and 2 times pi, because remember 2 pi is going to be the period of repetition of the sine and cosine functions. And we're just going to add that to the time times 2 inside the cosine function. And if I do this, we are going to have each of the pieces of grass starting at effectively a random point in the cycle, and they're all going to have the same amplitude and period of 2 pi seconds, about 6 1/3 seconds, but they're all going to be mixed up randomly, so that some of them are going to be like they'll be out of sync with each other, basically like this. And this is what Wizarducks does. Each grass instance has a random offset like this. I think it's actually the random offset is just like the instance ID or something. It's not important, but each grass object has a random offset like this, and the grass is just going to wave without any rhyme or reason. Again, perhaps not realistic, but good enough. If you want to make this a little bit more fancy, I'm not going to spend a ton of time messing with this equation further, but you can also say something like time times 2 plus x plus y or something like this. This is actually not going to look like much. This is still going to look pretty much random because the x and the y values are going to change from grass to grass object pretty quickly. Like, if we just move over a little bit in the room editor from like here to here, that's like 50 pixels, and it's big enough that it's basically random noise when your period is from 0 to 2 pi. So I'm going to just divide these all by, let's say, divide them by 50. And we now have some form of a pattern emerging in how the grass is swaying. So sort of going along this diagonal where my mouse cursor is, all of the grass objects are roughly in sync with each other, but across a horizontal or a vertical line on the screen, there will be there'll be some variation. And if you had enough of these, and if the room was big enough, you would see repeating patterns. You can be fancier with this. You can feed like the result of a noise function into here so that you can have some gradient noise, which is probably what some like fancier games, for lack of better terms, I don't want to say AAA because indies can do this too, but what fancier games which have more artistic looking grass might do. Feel free to take Perlin noise or something and feed it into this cosine function as an offset or something like that. But I think that's going to be it for now. I think I've had enough fun with this for today. So one last thing before I go, it is possible to do this in a shader without using draw sprite positioned. I am not going to do that. I'm just bringing it up because I know that if I don't, I'm going to get a million comments telling me about that. Wizarducks in the Lost Hat actually does do a lot of this in a shader, but that's for other unrelated reasons that make draw sprite position not a viable solution for that game. Maybe I'll make another video someday where I do discuss how to do this in a shader. That is not free. That has its own trade-offs and limitations, but just something to think about. And lastly, I was going to do this in this video, but it's already running a little long. You can take this a step further, and you can have the grass shake extra hard when, for example, your character or an enemy or an NPC runs through it. I might make another follow-up video someday where I go into more detail about that. But until then, you can think about that as homework. I will give you a hint. You can tack additional values onto this time offset to create different behaviors. So, my name is Michael. I like wizards and dragons and making games. If you want the code for this, you can find a link to a GitHub repository which contains it down in the description of the video. You should all go check out Wizarducks in the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff, and it is also where a lot of the examples in this video came from. Link to the Steam page can be found down below. I like to make videos on weird stuff you can do in GameMaker, so if anything like this or other weird shader stuff or 3D stuff appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. I hope you all found that useful, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Pixelated Pope, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, and Bokeh Dev for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description.